right, so far we've gone over just kind of the paper that you can use for the test, as well as my talking about kind of like how these tests are particularly difficult. Now we're going to head into what I call the tweaky wee. My hope is that eventually, like the day before the test, I'll say it's that time again, and everybody, like literally everybody, goes the tweaky wee, like those old like dumb television shows or whatever. That's my hope. I can't make any promises. Okay, things I would know if I were you. The tweaky wee. Number one, definitions. Definitions of what you say. Position, displacement, clock reading, time interval. Oops, I skipped one. Hold on. Distance, clock reading, time interval, average velocity, constant velocity, speed, instantaneous velocity, and acceleration. How all of them interplay with one another. Number two, constant velocity and average velocity problems. Number three, kinematic equations, aka specifically when the object is accelerating, because technically the constant velocity equation is a kinematic equation as well, and you got to know when to use it in its particular place. So I talk about the kinematic equations, again, I think I've said this before, usually when I talk about them generically, I'm talking about those four, specifically when it's accelerating, but ultimately kinematics means the description of motion, so literally an equation that describes motion is in play there. Number four, as it says, x versus t, v versus t, and a versus t graphs. I mentioned this the other day, I'll say it again. When it comes to these particular graphs, the way I train you on those type of problems on the homework are way more complicated than what I'll probably expect on the test. You could probably expect like 1, 2, maybe 3 different accelerations, so like 3 different shapes on a particular problem, but you're not going to expect anything like what you had to do as far as like, hey, someone's running a stop and go route, and then they get up to this particular velocity, and there's like 5 different sections or whatever. And when we do this, you're about to be free to ask any question that you want. I'm going to highly suggest that we begin with conceptual questions of, kind of like, all right, what is this, what is that, what is the other? And then after that, I'm willing to go into problems. I can make up problems on the spot. I'm willing to go over problems. I would highly suggest we don't spend a ton of time in 2.6 advanced kinematics, unless like that's where everybody is. And then the last thing I'll just say to this is ask good questions, and most importantly, if you're sitting there like, I don't know, but I think everybody else does, okay? 1, no they don't, this is physics. And 2, screw them, okay? You're not here for them, you're here for you. Ask your question. If you don't ask your question, you can't get mad about what grade you get on a test. You just can't, because it's your fault that you didn't prep the right way because you were embarrassed or whatever. All right, so what do you got?
Can you go over some average velocity problems?
Sure.
With the different velocities?
Yeah. Okay. So I'm going to go over a very basic average problem. Hey, look at that. Somebody's smiling at me. All right. Let's say that a person goes this way. Let's talk about actually average velocity versus speed versus distance and displacement. Yeah, anyway, we'll do it all. Okay. So the first thing, let's say this person walks across the front of the room and they just travel 4 meters across the front of the room. And then immediately they turn around and come back 2 meters. Okay? Do I want that? No, I wanted that first one to be 6. My apologies. 6 meters. They come back, it's 2. Okay, the whole process takes them 2.5 seconds. Now, when I say something like that, the whole process takes 2.5 seconds. You have to understand that that is a delta t. Okay, what are t's by themselves, and like when would you possibly use them? These are clock readings. So this doesn't usually happen on your homework because usually we talk about how much time has progressed. So almost always we're talking about time interval. But that would come up if I like literally said like, hey, Jerry starts running at 1:30, okay, and stops running at 4:30, okay. Then 1:30 would be time initial, 4:30 would be time final, blah blah blah. But yeah, what did I say? I said that was 2.5 seconds. All right, let's see if you can't figure this out quickly in your group. What is the speed and what is the velocity of this particular person in this situation? Discuss quickly. We're not going to take long, but let's go a minute or two, and then I'll go over it real quick.
Is the way going positive when you start?
It's up to you. I mean, I'm not going to tell you that in the problem. You know what? I'm sorry. I'm going to change this time. Shouldn't change much for you. Let's go to 4 seconds. I just want to make the numbers easy. All right, let's talk about speed. What's the major difference? Right, but I'm going to say specifically, you're right there, 100% right. It's dealing with distance as opposed to displacement. So, what's the total distance the person travels? Total distance that is traveled? 8 meters. Okay? Because 8 is the overall space. We don't care positive, negative, whatever. Right? So, what would the speed of this particular person be? 2 meters a second. Okay? What is the velocity of this person? Correct. Now, why did I particularly bring up this problem and why would I say this? Because here's the deal that students struggle with sometimes. On a test, I could say something to the effect of what is the speed of this particular person or what is the velocity of this person? And somebody not kind of trained is going to look at that and go, that's the same thing. And they're going to treat the problem the exact same way. If speed or velocity comes up specifically in like a multiple choice or problem, you need to go ding, 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 red lights. Okay, this is asking something entirely different for speed versus velocity. For example, let's change it. Let's change it this real quick so that we can do this in our head. Let's say the person walked all the way there and now all the way back for this second part. So now they're walking a total of 6 meters. What would their speed be if they did that in 4 seconds? 3 meters a second. Great. What's their velocity if they do that in 4 seconds? 0. Why? Because, why does that make sense? This is talking about average velocity here because they spent the exact same amount of time going that way as they spent going this way, right? So how far did they go in total during that time? 0. Average velocity kind of is like if it replaced the situation on its own, okay, you could get that exact same result. Meaning, let's say another problem here, real quick. Let's say this person is walking across the front of the room, okay, but they're jumping backwards and forwards at speeds or whatever. So here I am. I'm going to start here. 3. I'll count titles after. Okay, now walk across the front of the room. I'm going all over the place. I'm just bouncing back. I can't decide what it is I want to do, and the whole process takes me like, I don't know, let's say 8 seconds to walk over here. Okay? Can you talk about constant velocity? No, I was bouncing left and right, and there was a lot of times it was changing in there, and there was a whole bunch of different segments. But average velocity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. For sake of simplicity in math, let's say that process took me 5 seconds. While Spainhour was doing that crazy thing, and say there's a ghost Spainhour video game-esque that walks across the front of the room in 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. What was his average velocity? Same as the other. Okay? Average velocity can just take total displacement and divide by time and not give a crap about anything that's happening in between. Okay? What does that average velocity represent? Another person going at that exact thing the entire time and how much space they cover in total to the end. Does that make sense? Okay. All right, other questions? Yes?
Can we go over like a simple, basic, like X versus T?
Sure, be happy to. As a matter of fact, I'm going to say, here's what I would definitely have in your back pocket right now. Okay? There were 2 labs where these went with X versus T. X versus T. And 2 different scenarios that this is kind of with. Okay? 1, the toy car lab. The toy car was traveling at a constant velocity the entire time, so what was its shape? Linear. Now, for starters, just as a heads up, I'm going to erase this in just a second. Here is what yours looked like in the toy car lab. There it was. Why? Because the toy was traveling at the very beginning, and it started positive, and we forced it to go negative. Yes? Now, obviously, that doesn't make it the easiest thing in the world. So let's do this. This is the car starting in the positive side and just going in the positive direction. Let's talk about the V versus T's and the A versus T's that go with this. Okay? So, velocity versus time. Velocity looks at, well, let's start this. What is velocity on this graph?
The slope.
The slope. What is velocity? How is velocity seen on this graph? The y-axis. So you have to look and see what's the slope doing. A, I think it's fair to say the slope is positive, yes, and the slope is staying exactly the same, right? So velocity is positive and staying exactly the same. Right underneath that, let's do the A versus T for that, because it's like the easiest thing ever. As a matter of fact, I'm going to switch to red so it's obvious what these are. All right, what's acceleration? By definition, and anytime I hear you say by definition, anytime that like happens throughout this particular course, what Spainhour is doing is referencing the initial definition he gave you like 3 weeks ago. Okay? The purpose being, I want you guys to be able to use that same line of logic when you're doing something like this. Like, okay, shoot, I don't know what's going on. Let's go back to the definitions. I don't know what acceleration is. Oh, you do. Acceleration is the change in velocity over time. So we look at this graph and go, has velocity changed over time? Nope. How is acceleration seen on this graph? The slope. Has the slope is 0, the velocity is not changing over time, so the acceleration here should be 0. These shapes match up every time. If there's a linear shape, there is going to be a horizontal line, there is going to be 0 acceleration every time. Okay? So this is probably not a bad thing to put on that piece of paper, because if you at least have that in your back pocket, all you really have to do is ask the question in a situation, all right, are they accelerating or not? That's it. Okay? Now, the next one we talked about was the ramp lab. In the ramp lab, what shape was made? Now, the first thing I would probably suggest that you're able to do for the sake of, like, if you were asked to write a paragraph or a short answer. Oh, by the way, I wanted to talk about this. There's going to be short answer on this. Short answer means short. Okay? Short answer means probably 2 to 3 sentences. You always answer enough to answer the problem, but a lot of times people waste their time on short answer, answering these gigantic paragraphs of something, when ultimately I was looking for, like, it doesn't move. Like 3 words or something like that. So do be careful when it comes to the test with that. Okay. But one of the things on those short answer paragraphs that you should be able to look is, why does this curve? Well, the reason it curves is because the velocity is increasing. And we did this a few times. Velocity increasing means that the ratio of how much displacement you cover in a certain amount of time should then increase. In other words, we cover more space. We're covering more space in the same amount of time. so it makes sense that it should be curving up. Now let's talk about the v versus t and the a versus t of these. All right. What did my velocity begin at? 0. Okay. You can see that because right here, that tangent line, right? So right here, if I were to continue this way, as best as possible, you can see that it's at a 0 slope or 0 velocity at the very beginning. As opposed to, by the way, just so you can see it here, this is very importantly different. How are those two shapes different? No, both are accelerating right away. Both are accelerating. How do I know they're changing? Now they're both accelerating right away. They're both curving right away. They're both changing their velocity upward. So what is the difference between those two graphs? Nope, they're accelerating at the exact same amount. Look right here at the very beginning. That's what we're just talking about. Let me run through the list, okay, so you can spot it. Okay, do they have the same position? Yes, they start at the exact same 0. Okay, do they have the same initial velocity? No, there it is. Why do you look at those? How can you look at those and go, they don't have the exact same initial velocity? It's that same thing we just said a second ago, right? This, if I drew the tangent line right here, it would be horizontal. Which way would the tangent line go on that one? This one's already moving. Does that make sense? Okay, let's draw that one again real quick so you can see it. Let's try this from another point of view. This time, we're going to start up. This is a building in which a person takes a sandwich, I don't know why sandwich, and throws it straight down. What does that look like? Why does it look like that? Because it starts at a positive value. I should have told you I'm assuming that the ground is 0 and up is positive. My apologies. But notice right up carefully up here, this has an initial velocity. How is that different than if I just drop the sandwich? Then your shape needs to look like that. Do you see the difference? A couple things that you should notice there. And I'm just sketching it so it's not quite perfect. But one, obviously the initial velocity. But two, notice that does it take longer to hit the ground if I drop it versus throw it downward? Yeah, because it's not moving as fast. All right, back over here. My apologies. Kind of getting off topic. So, velocity versus time for the... Well, that's not what I wanted at all. Listen, I'm not a very smart man, computer, but you should be smarter than me. All right. What's my velocity begin at on the ramp lab over here? 0, correct? And then what's my velocity do throughout that particular shape? I like to just put my hand up, and if you do this on the test, you're great. So what's the velocity do? Slope goes up, 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 up. I can see right there it's getting more and more and more positive. Yes? So more and more and more positive. Acceleration, as we've discussed on this graph, you're really just checking if it's on or off and positive or negative. Is acceleration on? Yes, there's two ways that you can see that. One, you can see the curve up here. You can see that it is a positive x squared function, a positive parabola, which tells you it's a positive acceleration. Also right here, you can see that the slope is positive. Or you can just listen to the logic I said in the last sentence. The slope is starting from 0 and getting more and more and more positive, and therefore should be positive. Now let's say, for example, this situation was of a car, okay, that takes off and does a quarter-mile stretch, okay? And then after that quarter-mile stretch, they slam on the brakes in order to stop. For starters, what I just said, you should hear two accelerations. The first acceleration would be positive, okay? The second acceleration would be negative. The three graphs that we just drew, perfectly encapsulate this first time right here. The acceleration going that way. We're once again going to assume this is 0 and this is positive. I see your question. I'm just going to finish this real quick and then I'll be right there. Okay. What I'd like you to try to do right now, and then I'm going to show you to see how well you're doing, is see if you can't finish the next shape on all 3 graphs. What should the next shape be? Courtney.
So why would you not, on the second acceleration, go up from 0 and then do the acceleration, like a straight line up and then? Because if you're starting.
You're not starting. We're starting time when the person's already accelerating. Okay. We say that acceleration. You mean why am I not doing this?
Yeah.
Okay. Don't worry about that from the 0 position. Okay. We're just looking at that first time segment. You were technically right. It would technically have to come on fast. But basically, the moment this car has slammed the gas, okay, and the gas is in that particular spot, acceleration's on. Okay. What we in this class assume is that that foot pressing on the gas happened instantaneously. Now, is that accurate? No, but it's pretty darn close to accurate because in all truth, it's actually just a very, very steep line. So we're going to say it turns on immediately. So again, point being, don't worry about anything that happens at time 0. We'll just say it's already starting. You just want to look at that first time segment here. I'm going to work my way backwards. We usually always go from X to A. I'm going to go from A to X right now. Okay? Let's start with this. Okay? Acceleration on that second half. What should it be on, off, positive, negative? What you got? Remember here, I'm speeding up because of the gas, and at this point in time, that second half, we are braking now. So what's happening to my velocity? Well, my velocity in this first segment started at 0 and ding, 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 up to some high number, right? Now, because of the brakes, what's my velocity doing? What's that? Decreasing to 0. Or more importantly, not even decreasing is what you're right, but not looking at decreasing, but it's heading in what direction? The negative direction. So that means acceleration should be negative in that time segment. Now, even though acceleration is negative, should the velocity stay positive the entire time? Yes. How come? What tells you that the velocity of this car should stay positive the entire time? Not quite. Not quite. Get the right idea, though. Same question. I think you guys are on the right page. I'm just going to say it a little bit differently. Basically, the car keeps going that way, right? It keeps going in the positive direction. What would the car have to do to have a negative velocity? Since it's not, it should never have a negative velocity. Also, the other thing you can kind of look at is what is its end goal? Well, what is the velocity going to be at the very end? It's going to be 0. So there it is. And notice I have a negative acceleration and a negative slope. This might be helpful to do it from this direction because this automatically tells you what shape should be on this last guy over here. What shape should be on the x versus t graph? Parabola, positive or negative? Negative. So I make this smooth into this guy right here. There it is. Somebody asked this the other day, and I don't know if it's in here or the other class, so I'm just going to ask the same question again. Why does this one stop at 0, but that one doesn't stop at 0? Correct. Position's not at 0 at all, but why does this one go to 0? Velocity did go back to 0. They started at 0, they ended at 0. All right, other questions? You can open this up to problems as well. How are we doing on the Ranger problem?
Is there going to be a problem like that on the test?
Very late. I'm sorry, not very late. There's definitely going to be a problem where there's multiple accelerations on the test. So, like that, in that there are multiple accelerations, yes. Like that, in that you have to kind of use your problem-solving technique and not just like, listen, I do not try on a test. I do my best to give you problems that are doable if you have the skills, but are not just copy and paste from problems you've seen previously. Okay? They should be very easy if you have the skills. I don't try to overcomplicate it or make this kind of crazy amount of work, what I consider a crazy amount of work. But I am looking at, do you have, I don't want to teach people that, oh, well, if you can do problems 7, 8, and 9 on this homework assignment, that's on the test. So 7, 8, and 9, that teaches you to copy, that doesn't teach you to think. So to that end, this makes you think. So yes.
Are there going to be any questions where we have to use substitution or elimination options?
Excellent question. I said this the other day, I'll remind you. So I call those system of equations where you have to develop two equations, two unknowns. The answer is yes and no. Yes, it's on there, it's a bonus. 100% bonus. Also, heads up, points on my test are front loaded. Okay? If you're running out of time, especially, please understand that you get a bulk of the points by following those steps that I talked about early on. I expect Jafeeps on your problem. Write the givens, write the find, write that picture. All of that's worth points. Even if you don't freaking finish the problem. Okay, look, and I do this because the AP test does this. The AP test is stupid hard, but you get like a point on most problems if you simply write down the correct equation that you should be using on that particular problem. So it's the same thing there. So this is showing me that you kind of know where this is going. So if you are running out of time, then you want to make sure and cover definitely the easier ones because you're going to get more points there, but also like the front part of that. I say that to then say, do not necessarily skip to like the end of the test, find the difficult one and try to do that bonus first, because if you run out of time, the amount of time effort for how many points you get is not that great. Okay. To that end, I would say you're gonna have a 50 minutes to take this test. You're gonna want every single second of the 50 minutes. I would usually suggest somewhere between about 15 to 20 minutes for the 10 multiple choice. That sounds like a lot of time for multiple choice, but my multiple choice are not gimmies, okay, and are worth like half the points. A lot of students coming in to my test kind of blow through that. They don't pay attention to it. They focus on the problems because problems, except I can't give partial credit on multiple choice. So you miss two multiple choice out of 50%. That's 10% of the grade. So that can hit you kind of hard right there. So do consider that when you're doing your time. Other questions? Yes.
Are like the intro skills going to be on there?
Excellent question. Very good question. No. Okay. There's not going to be any linear regression. There's not going to be any graphing. We usually cover that specifically on labs and seeing that stuff. That stuff takes a lot of time. I don't want to waste a ton of time doing that. This will be primarily focused on kinematics. I don't think there is anything from chapter 1 outside of obviously stuff that you would naturally use. Maybe some unit analysis because that's throughout. If I find there is, I'll look at it this afternoon. Okay. If I do find that there's any like chapter 1 stuff on there, I obviously want to make sure I'm not like hiding stuff from you. I'll post like a message online like, hey, I was wrong. There's this, but I'm pretty sure there's no chapter 1 stuff at all on this test. It is primarily, like I said, on the tweaky we just a second ago, those things, the definitions, the concept velocity, average velocity, the kinematic equations, and x versus t, v versus t. Other questions? Yes.
How many like questions and problems?
So there's about 10 multiple choice. Usually on short answer, there's somewhere 2 to 3, and usually problems, it's about 3. Okay, 3 required, 4 if you're probably doing that bonus. But again, the bonus is not a lot of points. If you don't get to it, not need to be worried. And again, the points are front loaded. So if you get I think I said this the other day, but that's primarily most of the points you're going to get on the bonuses. Develop the equations. Do the math. I don't care necessarily. You can, but it's not going to be that many points. Other questions? Yes.
Could we do a question where like you're given like a velocity, like you're going 5 meters per second for 5 seconds, and then
Sure. I mean that's fine, but that's just. Oops. Where am I at? Oh, why'd you move down there? Why are you doing this? It'll be difficult. Now I'm. All right. I can't. That's really annoying. Are you kidding me right now? I don't want to stop because I don't want to. It's not what you should be focused on. Automatically hide the taskbar. There you go. Cool. I mean, sure, but it's just going to be something like, hey, person is out running 4 meters at a speed of, let's go 4 meters a second. Okay. And then they're running, let's go 8 meters per second. So much faster for a total of 8 meters. Nope, that's dumb. That's dumb. 60 meters. Is that right? Yeah. Okay. So what do you have to do here? Well, your definition of average velocity is total displacement over total time. So you've been kind of doing something like this even before we did this. What I would do is I would call this displacement 1. I would call this displacement 2, velocity 1, velocity 2. Use those subscripts to your advantage. Okay. Now, to find the average velocity of the total trip, I need the total displacement. That's easy. That's 20. Okay. But I also need the total time, which of course I don't have. But what I can do is for each one of these in here, so these two equations are, well, actually, let me go back. Hold on. These are identical but different. Okay? What do you mean by that? Well, this is the constant velocity equation, and this is the average velocity equation. But Spain over, they're completely identical. Yes, the limitation is this. This can talk about the total, but that one can only talk about when it's constant velocity. So this would be, use your correct subscripts, v1, vx, v delta t1. Okay? So what can I do with that? Do my algebra, see that delta t1 is equal to delta x1 over v1, and that takes my 4 meters divided by 4 meters per second to see that it takes me 1 second to travel that first guy right there, right? Then, I've already done the algebra, so I'll just do it again. Delta T2 is delta X2 over V2, or 16 meters over 8 meters per second for 2 seconds, right? So, how do I get the average velocity? We come back over here. We get that the total is 20 meters, and we get that the total time is 3 seconds. And what do we end up with? We end up with, let's see, 6.67. And it makes sense that it should be closer to the 8 than the 4 because we were in that time lock. That's it. Yeah, that's all it is. Now, the only other piece that might add a little bit of shade of difficulty in here is if I said that this person, notice by the way, they don't worry about acceleration at all in these problems. But let's say I said included in this at the very end of this, I said that they stopped for a total of 7 seconds. Technically, that's a third time, okay? And obviously, the displacement of the third section is 0, right? Because the velocity of the third section is 0, but the total time is 7 seconds, which then changes stuff how? Well, now I still traveled 20 meters, but if I add that into my whole thing, it took me a total of 10 seconds, which means my average is no longer 6.67, but 2. And why would it make sense that these dropped all the way below 4 and below 8? Because we spent so much time at 0 that obviously the average drops further and further and further. Any other questions? I do have a few things going on this weekend. I have a funeral, and I'm going to visit some family. But please do feel free to post questions to my email if you're struggling with a particular concept. If you need extra bonus problems, I told somebody today I was going to try to make like 5 or 6 and throw them together and send your way, but they're not going to be bonus or anything. They're just going to be practice. That being said, if that's you, I would probably suggest you use the textbook first. Like find the textbook, find a problem, and be like, hey, this is one I don't know if I would do well on the test. I don't think I could do this on my own. Then what you do is you look at the problem and you try to do it yourself. Don't look at the thing at all. Literally don't look at it. Try to do it yourself. See if you get stuck. If you don't, great, you're ready. And if you do get stuck, then you can look at the textbook and go, hey, right here is where the struggle is. So the only problem with me sending you problems is I mean, the best I can kind of do for you is give you the answer. But I think that some of you guys know this, hopefully, that you do a problem, you make one small mistake, and you get the wrong answer, and that feels bad. But I want you to understand that if I'm grading that on your test, this happened to Cameron just yesterday. Forgot like a small square, and the whole problem blew up. But as I told her, like, look, I'm looking at your work. I'm not looking at the final answer. I know it feels good to get the final answer, but if I'm looking at that work, I'm giving it 9 out of 10. You made one small mistake. Obviously, we don't want you to do that, so I'm taking off that point. But we're doing partial credit. Also, some of you guys have potentially seen a code appear on your tests or homework and maybe don't know what it means. It's RAW number. What that means, and I want you to know that I do this, is if you make a mistake early in the problem, I take your number and do the calculations moving on with it. Meaning, like, if you do the rest of the problem entirely right, obviously you're not going to end up with the right answer, but because you had the wrong numbers, but you're not losing points for this. So if you ever see right answer, wrong number, it means, hey, you did the section completely right. You're not getting the right answer because of a mistake I already took off earlier in the problem. So you're not missing like 2 points for like one small mistake. So I just want you to know that I do check that to see if if that's the deal. Other question? Yes.
Will there be different levels of difficulty for the question and test, or will they all pretty much be?
Certainly, absolutely. There will be all levels of. I try to encompass the entire chapter. Okay. There might be a little bit heavy on towards the end, only because the problems towards the end used everything from the chapter, right? So like a problem where, like a free fall problem, where like, or like the laden swallow problem, where like you had the swallow and you threw it up in the air and you had to calculate delta x, the max height. You have to recognize that that delta x comes from this spot, right? And so max height includes that initial position right there. So that type of question, for me as a teacher, stresses, okay, did they do the kinematics? Great. They also understand the difference between delta x and x, and that covers that definitions side of things as well. So I can do a later problem and be testing for multiple things and throughout. So to that end, there's probably a little bit heavier side to some of the more recent problems, but no, there are problems throughout. I would say biggest struggle probably on the test for most students early on is time management. I will tell you on the test on Monday, I will tell you after about 18 minutes have passed, and that's right around the spot where you should probably be finishing your multiple choice. Some people can certainly finish it faster if you just know the stuff really well, but if you're kind of taking a little bit of time, 18 minutes. Short answer should probably take you somewhere between like 5 to 7 minutes, putting you at 25 minutes. And then the last half of the class period, 25 minutes to do like three or so problems. Okay. Also, again, I grade given, find, equation, algebra, plug in, and solve. Meaning, I don't care if you do the problem perfectly. Okay, if you have the right answer on the end, but you're skipping that earlier stuff, I will be taking off points, which doesn't entirely seem fair until you recognize that I'm not grading the answer, I'm grading your thought process. I'm grading the work. So if you don't have work, then yes, I will be taking it off even if you do have the right answer. Small thing, circle your answers when you're done. Just takes no time at all, and it makes it really obvious. Other thing, for some of you in here, organizing your problems, thinking about what you put where, is invaluable not just for me as a grader, but for you as a thinker. If you run out of time, a lot of times it's because you spent way too much time trying to find stuff because you didn't organize it well in your problem. So think about that, where you put it. Other questions? You didn't have very many questions. That's awesome. I hope that means we're ready. I will post this video. Obviously, you guys are here. You don't need it. I will also post a video for second hours questions as well. If you want to flip through, if you can. Obviously, they're probably going to ask a lot of the same things. So, cool. All right. You heard me on there too. I will post second hours questions as well. If you guys have questions, shoot me an email.